Hi folks, welcome back to chapter 6.2. We're talking today about the similarity of figures and whether two figures are similar to each other, figuring out how to calculate that or to figure that out. First, let's do a quick review of last lesson where we looked at some scale factors. And in this problem, we've got a room that's 20 feet long, 16 feet wide, and 8 feet high. And we're given a scale factor of 1 foot being represented by 2.5 centimeters. So if you want to build this model based on this, how big are you going to make your little model? So first, we're going to start by taking a look at our scale factor. We set up our scale factor as 2.5 centimeters over 1 foot. That's model over original. So if 2 centimeters equals 1 foot, we're going to have the same proportion when we have 20 feet on the bottom. How do we calculate this missing one, the model size for that ball? We take this and we multiply it together and then divide by this number here, which is just 1, make it super easy. 2.5 centimeters times 20 feet is 50 centimeter feet divided by 1 foot, 50 centimeters. So that's 2.5 times 20 divided by 1. Now, if we want to figure out the next one, we're going to look at 16 feet wide. And again, the original goes on the bottom, model goes on top. And we're going to do 16 feet times 2.5 centimeters divided by 1. Of course, dividing by 1 just leaves it the same, so we don't really need to do that. But it's good practice to always have that in there. So this is going to be 32 plus 8 is 40 centimeters. And finally, last dimension here, we have 8 feet high. And so this is going to be 8 times 2.5 divided by 1. 8 times 2.5 is 20 centimeters. If you're building this scale model, we're going to build it 50 centimeters by 40 centimeters by 20 centimeters. All right, moving forward into section 6.2. Remember what it means for two polygons to be similar. When two polygons are similar, your corresponding angles are equal, so the numbers have to be exactly the same, and your corresponding sides are proportional, so they have the same scale factor. So let's take a look at an example and see if we can figure out if they are similar. We have two pentagons below, or here. Now they're pentagons because they have 5 sides, not because they're in the shape of a regular pentagon. In fact, they look more like rectangles with corners cut out of them. But that's just the way things are going to be. So are the two pentagons below similar? So in order to determine this, we have to figure out if all the angles are similar. Any angle marked with the same symbol are equal. So we have A and R that are equal. That's great. We have this X in both of these, so C and T are equal. Also great, so far so good. E and V are equal. S and B look kind of the same. Could they be different? They probably could. What about U and D? They look kind of the same, but I can't guarantee that they are. Okay, well, let's see. Is there any way for us to make it so that S is different between B and C? Well, yeah, we could make this longer. No, because that would change that angle. Anyway, the long and the short of it is we can't prove that S and B are the same or that U and D are the same. Therefore, we cannot say for certain that this is a similar polygon. If we knew those angles, we could look at the side lengths. 5 centimeters to 2.5 centimeters, this is twice as big. 6 centimeters to 3 centimeters, that's twice as big. So that would lend to the idea that they're similar, but we can't prove that they are. because we could shorten this top bit, which would make this shorter and this longer, and then would change the angle of the, right? There's some things we could do to make them non-similar with those angles and sides as listed. Or we can't prove that they're the same. All right, so I guess I should write that down. Are the two pentagons below similar? We can't say for sure. Angle B and angle S could be different, and angle D and angle U could be different. Okay, so let's take a look at the next example. Example page 267, we got a couple of parallelograms. So in parallelograms, remember, that means that this is the same length as this. This is the same length as this. And similarly, this is also 70 degrees, and these are both going to be 110. They're parallel, so when we have a transversal, these two angles are supplementary. Hopefully you remember that from last chapter. Okay, so we know that those are 70, 110, 70, 110. We also know this is going to be 70, 70, 110, and 110, because they're both parallelograms. All right, so then the question is, are these two similar? Compare angles, all good. Compare side ratios. So what's the side ratio of AB to WX? It is 8 inches over 6 inches, which when you reduce it, you get 4/3. Okay, so that's my ratio from AB to WX. What if we did BD to XY? For these to be similar, these should both be the same ratio. Let's do this. 12 inches divided by 8 inches. We're going to reduce that by dividing top and bottom by 4. And that's equal to 3/2. So we have different side ratios. They're not to scale. They're not to the same scale. Therefore, these two parallelograms, even though they look really similar, don't they, are not similar figures by our mathematical definition. And that's it for lesson 6.2. Hope you enjoyed it. Best of luck with the work. If you have any questions, please feel free to join me at 2:15, and I'll help you out.